All right, good evening. My name is Kenneth Powell Jr., and this is Milestone, one of my project, the Behavioral Health Compliance Checker. For this milestone, the goal was to build the foundation of the system. That includes creating a form to collect data, setting up a database to store that data, and connecting everything together so it actually works end to end. I'm going to start with a live demo, then walk through the code, rebuild the app from scratch, and finish with what I learned and the issues I ran into. So let me start by running the application. Okay, as you can see here, connects through the browser. All right, and so it takes us to this form. So this is the form. I kept the design simple because the focus here is functionality, not styling. These are the four fields I'm collecting: client ID, emission date, assessment type, and completion date. So I'm going to enter some preliminary data just to show the functionality of the form. Then I'm going to submit the record. Right. So as you can see here, we have a success message that says record saved successfully. That means the backend logic ran, but I still want to confirm the data actually made it into the database. And so for that, we're going to go back to my terminal. I'm going to with the application, and to verify the database, I'm going to just enter. Um, Well, actually, I created a file specifically for this. It's called check db.py. And so it's just some preliminary code here. One telling it to access the this specific database, telling it to select, from the records and to gather all the records. Initially, when I first created this file, I didn't have this line in, and it pulled just the fact that it had a table. So this line right here, it it directs the code to pull the specific data from each row. So I'm going to run that as we speak. Right, and as we can see, so we can ignore these first four rows. Those are other test forms I submitted. And the bottom row, as we can see, the 3467 client ID I entered, today's date, diagnostic assessment, and also today's date for the completion date. All right. So now I know the full flow works from the front, from the form to the back end to the database. Now I'll walk through the code and explain not just what I did, but why I made certain decisions. Starting with the app.py file. So this file controls the main behavior of the application. I'm using Flask, which is a lightweight web framework. A web framework is basically a tool that helps you build web applications without writing everything from scratch. I could have used something like Django, which is more powerful, but it comes with more setup and complexity. For this project, Flask was the better choice because it's simple and easier to control. And if I can turn your attention to my code, so this line here, this is what I use to create the Flask instance, the Flask app instance, excuse me. And let's see where, and this line here. So this route handles the home page, and a route just means a URL path. In this case, the root path, which is slash. I allow both GET and POST requests. So GET is used when the browser is just loading the page, and POST is used when the user submits the form and sends data to the server. I could have split this into two separate routes, but combining them keeps the logic in one place, which is easier to manage at this level. So when the form is submitted, I use request.form.get to pull each value as seen here. This works because when a form is submitted, the browser sends key value pairs to the server, and Flask makes them available through request.form. I use .get instead of direct access because it's safer. If something is missing, it won't crash the app. I also added validation. So validation just means checking the data before I use it. In this case, I check if any fields are empty, as we can see, and as we can see here. And if no, as we can see here, errors equals zero. So if none of the fields are empty, it will insert the following records and provide this message. So I could have skipped validation, but that would allow bad data into the database, which would cause problems later when building compliance rules, excuse me. The next file I will discuss is the database.py file. So this file handles the database operations. I separated this from the app.py to keep things organized. I could have put everything in one file, but separating concerns makes the code easier to maintain and scale later. This, let's see. Oh, where is it? Oh, excuse me. So this portion here, come, don't embarrass me in front of company. So this portion here creates the table. I use create table if not exists so the app doesn't crash if the table is already there. The next portion I'm proud of, I use parameterized queries. When inserting data, I use what is called a parameterized query. A parameterized query means instead of putting values directly into the SQL statement, I use placeholders like question marks and pass the actual values separately, as demonstrated here. For example, instead of writing a query with values directly inside it, I pass the values as a separate tuple. This is important because it prevents something called SQL injection. What is SQL injection? Glad you asked. So SQL injection is a security issue where a user enters malicious input that changes how the database query runs. For example, if someone types SQL code into a form field and the app directly enters that into a query, it could allow them to read or delete data. Parameterized queries prevent that by treating all input as data, not as executable code. So even if someone enters something malicious, it won't be executed as SQL. This is a standard best practice in software development. So I've read. So why did I use SQLite? So I used SQLite as the database. SQLite is a file-based database, which means it stores everything in a single file. I chose it because it's simple and requires no setup. Other options like MySQL or PostgreSQL are more powerful, but they require running a separate database server. For this project, SQLite is the best choice because it's lightweight and easy to work with, especially with my learning curve. Next, I want to turn your attention to the HTML template. So this is the HTML form. HTML is what defines the structure of the page. The form uses method post to send data to the server. I used input type date for the date fields. Hold on. First, I want to turn your attention to where I actually use. Yeah. So I used input type date for the date fields as illustrated. My fault. I didn't want to breeze past this, but here's the post. Here's the post action. But anyway, so I used the date. Here we go for, as you can see here, for admission date, and here for input type for completion date. So this is better than using a text field because it enforces the correct format and reduces errors. For assessment type, I used the drop down, and that was the design decision to control the possible values. If I use the text input, users can enter anything, which will make the data inconsistent. As demonstrated here, we can see all of the option values for the assessment type. I also used Ginger templating. Ginger allows the backend to send dynamic content into the HTML. For example, displaying success messages or error messages. So a quick example of that would be here with this section for the error message. Mhm. Now I'm going to rebuild the application from scratch. I've already deleted there was a dist file and a build file over here in the in my file explorer. I've already deleted that in preparation for the demonstration. So here I'll just go back to the terminal and I'll run the Pyinstaller. 1 second. All right, so that is building the necessary files, and then I'm going to go to the my system file explorer, open the executable file, and run the app from there. Okay, oh wait, there we go. Okay. All right, boom, boom, and as we can see, the form opens up as usual. I'm going to enter another record just to demonstrate its use. And as you can see, record saved successfully. I'll go back to this. Okay. All right. So there was a lot of research that went into completing this phase of the project. So for this milestone, I focused on learning how Flask handles routing and form submission. Also learned how post requests work and how data is passed from the front end to the back end. I researched SQLite because it's the simplest way to store data locally. I also learned about Ginger templates for connecting back-end logic to the front end. I ran into several challenges. Several. One was getting the virtual environment set up and recognized properly. There was a tough battle that I encountered when the virtual environment would not initialize within my cloned repository. That was very problematic. I also had issues where the Python interpreter wasn't detected. At one point, I forgot to import a function, which caused an error. Literally, as a matter of fact, literally right up here, I forgot the insert record portion. Um, learning a lot, just using SQL, using Python, just learning a lot all at all at once. And it's been a very interesting journey. Um, Also had a situation where the database looked empty, but I realized I wasn't querying it correctly, and so that's what I learned with the check DB file. I didn't have this portion and it caused some in this push well, and it caused it just brought up a blank a blank table. Rookie mistake. Um And then also building the executable requires some trial and error to understand how the output folders work. Just yeah, that was a journey. This has been a journey. This has been a learning experience to say the least. So this milestone helped me to understand how all the pieces connect. The front end collects data, Flask processes it, and the database stores it. I also learned how to debug problems step by step. Big shout out to Google, please. And I made design decisions. And I made design decisions, excuse me, based on simplicity, safety, and clarity. That's everything for Milestone One. Thank you for your time.